Let us now discuss next numerical. The question says that there is a transmitter which is again AM DSB-FC. It has a carrier power of 10 watts. So carrier power is PC. PC is the notation we use for the carrier power. The question says is equal to 10, and it is the value at a frequency 25 megahertz. That means the carrier frequency which is given in the question is 25 megahertz, and it operates into a 50 ohm load. So load resistance RL is also given as 50 ohms. Please note that whenever any load resistance is not mentioned, we always take RL equal to 1 ohm. As of now, it's given to be 50 ohms, so we'll use this value. It says it is modulated. That means the carrier is modulated at 60%. So modulated at 60% simply means that modulation index M is equal to 0.6. It's 60 by 100, which will be 0.6 by 2 kilohertz sine wave. 2 kilohertz sine wave means FM is given to be 2 kilohertz, the modulating signal frequency. These are the various values or the information that is given to us. There are questions like draw the signal in the frequency domain showing power and frequency values. So we have to basically draw the frequency spectrum of the signal. So that's the first question. In the second question, we have to find out what is the total signal power. So find total signal power. The notation we use for the total signal power is nothing but PT. And then we have to find out what is the RMS voltage of the signal. RMS voltage of the signal can be written as VT. Okay, now let's quickly understand the solution of the question. We can immediately draw the frequency spectrum. The frequency spectrum of the signal can be drawn as one-sided spectrum or two-sided spectrum. Generally, any frequency spectrum is two-sided frequency spectrum. But even if I stick to only one side, let's say, in that case, we have to mainly show all the frequencies present in double sideband full carrier signal. The very first frequency is always the carrier frequency itself. The second frequency on the right hand side will be FC plus FM, and one frequency before that will be FC minus FM. So these are nothing but the carrier frequency, upper sideband and lower sideband frequencies. The amplitude of the carrier frequency and hence its power will be maximum, and the amplitude of upper and lower sideband frequencies will be small values compared to the carrier frequency. So these are nothing but the impulses corresponding to all the three frequencies that we have in the signal. I can draw the same three impulses on the other side also to have two-sided representation. So in that case, there will be a impulse at minus FC plus FM, and minus FC minus FM. If I just show the three impulses on the right hand side in this case, then we need the very first thing we need is the values of all the frequencies. So the carrier frequency in the question is given to be 25 megahertz. FC plus FM will be nothing but 25 mega plus FM is given to be 2 kilohertz, so that will be the value, which will be 25.002 megahertz, and FC minus FM will be 25 mega minus 2k, which will be 24.998 megahertz. These are the frequency values. Now let us find out power of each and every frequency component, because question says draw frequency spectrum with frequency and power values shown in the spectrum. So when it comes to finding the power values, we will first find the carrier power, which is VC. The question has mentioned the carrier power of 10 watts in the question. So that is something we don't have to find. It is already given to us. So the carrier power PC, I'll just mention PC equal to 10 watts here. To find the power of the sideband frequencies, we can first find the total power. Total power has the formula PT equal to PC into 1 plus M square by 2. Now in this case, the load resistance doesn't come into picture because both PT and PC are found with the same value of RL. So whether it is given or not given, it will anyways cancel out. This expression of the total power remains same. PC is 10, 1 plus M is given as 0.6. So 0.6 square divided by 2. If we solve this, the total power comes out to be 11.8 watts. Now there are various ways in which you can find the sideband power also. A very logical way would be to first find the total sideband power, which will be the total power minus the carrier power. The total power is 11.8 and the carrier power is 10 as given in the question. So the total sideband power becomes 1.8 watts. And as we already know, upper sideband and lower sideband both are of equal amplitude, and hence they will have equal power as well. So the total sideband power will divide into 2. So the sideband power will be nothing but 0.9 watts. So this is the value we were looking for. Upper sideband power is 0.9 watts and the lower sideband power is also 0.9 watts. So this is the complete frequency spectrum with corresponding power values.